Hi, I'm Derek Robinson. I'm a senior online course developer here at InterSystems. And in this video, we're going to talk a little bit about RAG architecture, or retrieval-augmented generation, and why it might be beneficial to use as the architecture for your generative AI application. Now, other materials go into a little bit of a deeper dive on what RAG is and some of the use cases that you might find most relevant for RAG architectures, but let's do a quick refresher on kind of the workflow through a RAG architecture before we take a look at some of its key benefits. So with most generative AI applications, you'll start with a user who's going to ask a question or submit a prompt to whatever the application is. So for instance, when we use ChatGPT, we ask it a question, and for the most part, in a normal interaction like that, this prompt is going to go directly to the LLM, and the LLM, based on what its training data says and the way it's been trained completely, will give the best answer that it can to that question. Well, with RAG, there are a few more pieces that are added to the architecture. The first one that we're going to look at is embeddings models, or what is used to create vector embeddings. Now, we're not going to go into vector embeddings in this video, but basically those multidimensional items are what are really used to help us create a similarity search to retrieve the information that we're going to retrieve. But basically, when you have all of your content that's going to make up the specific info for your RAG application that is going to be used as the source of truth, that content will be run through an embeddings model to create vector embeddings for all of that content that can be stored in vector storage. So whether you're using InterSystems Iris and its vector search capabilities, or you're using some other vector database, basically all of your vector embeddings will be stored in your vector storage location to be used as the information that your application is going to retrieve to be able to augment responses to the user. So coming back to the user's prompt, one of the first things that will happen here is that this prompt is going to also go through the same or a compatible embeddings model to become a vector embedding as well. So if you create a vector embedding directly from this prompt, what that enables is the ability to run a similarity search. Oftentimes this is using cosine similarity, but as the developer, you really are in control of many of the aspects of your retrieval mechanism and how this data is going to be retrieved from vector storage. But let's say, for instance, that you want to pull the 5 chunks of information from your vector storage that are the closest in similarity to the embedding that you've created for this question. So basically the question becomes an embedding, and we can pull all the relevant information from your vector storage, and that relevant information is now pulled from those embeddings and loaded into this prompt here to be able to have a prompt that is much more full of information and context than the original question that the user submitted. Now, that question the user submitted also goes into this prompt, and so ultimately this prompt doesn't contain any vector embeddings in it, but it contains all of the context that came from those embeddings to be able to give a full set of information with the question to the LLM to best equip it to give an answer. So you're now using the strengths of the LLM to be able to generate and craft that response, but using this RAG architecture, you're really tailoring what the context is going to be and what relevant information is going to be used to generate that response, or in other words, augmenting that response with your specific information. So from there, the LLM then will generate the output just like any other interaction with an LLM would do, and the output is then going to be shown to the user with that information and really relying on the retrieved information that you've set up your application to utilize. So this is kind of a quick run through of how the RAG architecture works. Now let's take a look at some of the benefits and some of the reasons why you might choose this RAG architecture as the architecture for your generative AI application. All right, so now that we've taken a look at what RAG architectures really are and given a little bit of a refresher on how they work, let's look at 5 key areas that provide benefits when it comes to a developer looking at a RAG architecture for their application. So the first one we're going to look at is customization. And so kind of going along the same lines as we talked about before with the travel application example, what customization really allows you to do in a RAG architecture, you can choose what information is going to be used to help generate those responses. So maybe you have successful travel itineraries that you'd like to rely on, or you might have travel articles from trusted tourism sites or authors that you want to use. Or you might have, certain prices and historical price data and user reviews and things like that that you'd like to all roll in. So you can really choose what information is being utilized by your RAG application. The next one that we have is real time. So this is a benefit that really can shine in certain applications. If you consider maybe a financial services application that you're building that's going to give tailored investment advice based on the user's query. Well, you may have wealths and wealths of historical data that can be used with all kinds of different information that can give trusted responses on investment advice, but you may also want to incorporate real-time stock market data, for example. And so by building your architecture in a RAG architecture, you can be able to incorporate into your retrieval mechanism some real-time information pulling to be able to pull the latest stock market data to help augment the response that goes to the user. So real-time is another big benefit of RAG. The next one is accuracy or relevancy. And so this one is really at the heart of what the RAG architecture can provide as far as benefits go. It really is aligned quite well with the customization idea, but consider a scenario where you're building a chatbot that is a support application for a product, right? So you can have all the product documentation, you can have all the information that this model needs to be trained on to be able to give efficient and informed responses to a user asking for help with the product. But you might want to go a step further and say, hey, we have all of these, completed support tickets that we want to inform the answers. We might have the latest user feedback that we want to be considered. We might have updated release manuals or release notes from the product that we want to add. And so by adding all of these customized pieces of information, we can really give a much more honed in answer than what you get when you ask, considering a large language model that's trained on the whole internet, for example. You're really trying to thread a needle by getting the correct response to a really detailed question. With a RAG architecture, you can give it that specific information that supports the answer that most of your users may be asking. So you can really improve your accuracy and relevancy with a RAG architecture. The next one we have is modular. So one of the benefits here of a RAG architecture is that its modular nature can allow you to make updates to one piece of the application without having to touch other parts of it that may be just the way you want them currently. So if you consider an application that may be a news summary generator, so perhaps it's going to look at news that's relevant to a user and be able to generate summaries or highlights for that user to be able to give them the snippets of news that they want. Well, maybe over time you decide that you need to kind of tweak the accuracy and relevancy of the articles that are coming in for this user that they want to be able to get informed about. And so without actually adjusting the LLM or the actual piece of the application that generates the response to the user, maybe you love the way those responses are being generated, you just want different articles to be shown to them. By the modular nature of a RAG application, you can tweak the retrieval mechanism in your application without touching the rest of it. And that way you can adjust the weights of what similarity searches are going to be done and how that information is going to be augmenting the responses that the application gives. And so by having this modular architecture, you can make adjustments to one piece without having to overhaul everything. And so the last point here is a very similar note here is scalability. And so scalability goes hand in hand with the modular nature of these RAG architectures, but scalability is referring to the ability to have your data set, your trusted data set that informs these responses, grow over time without the constant need to retrain the model over and over again. So if you consider the scenario where you maybe have a healthcare application that would like to utilize the latest clinical research and patient data to be able to create informed diagnostic suggestions, for example. By having a RAG architecture that you can inherently scale by having that data set, the data set that was up in the corner in the original architecture diagram before, that vector storage can grow and grow with relevant information, and you don't have to adjust the model every time, you don't have to retrain the model every time. You can really scale this to grow with your growing data set and continue to see improved accuracy and relevancy as you can tweak your retrieval mechanism and expand the amount of data at its arsenal to be able to generate those responses. So these are just 5 areas that RAG can be beneficial as you're choosing how to build your generative AI application. RAG is also not the only way that you can build a generative AI application, but you probably have seen across many other videos that it has kind of taken the industry by storm a bit, and it's been the architecture that's been talked about quite a bit. So hopefully this video gave you a little bit of an understanding of why that's been so popular and some of the benefits that you have when you choose to build your application using a retrieval-augmented generation approach.